Alright, so for this problem, we want to get the nth digit back. Let's go ahead and take a look at that. Nth digit back. So if I want to get the 0th digit back, that means the 0th digit from the counting from the right. So this gives me 3, 1 gives me 2, 2 gives me 1, right? So this problem says, let's take in two integers, n and num. I will find the nth lowest order digit, right? Meaning, lowest order meaning from the back, from the ones place, as opposed to the next problem, which is the highest order, which is going from the left to the right, as opposed to right to left. Here we are doing right to left. So here, 0 gives right is the ones place, 1, 2, 2, gives me this 1 over here, right, gives me what's in the hundreds place. 3 gives me would give me what's in the thousands place, right? But there is nothing in the thousands place, right? I mean, it would kind of make sense, actually, if we think about this for a second. How so? How does this make sense? Well, the way it makes sense is that the ones place is technically some number, right? Some is the digit multiplied by 10 to the 0th power. The tens place is the digit from 10 to the first power, right? And this digit over here is 10 to the second power. So the hundredths place is the 10 to the second power. 10 to the first power, 10 to the 0th power, 10 to the first power, 10 to the 100th power. Pretty cool. All right. So, and where does that 3 come in? Well, just imagine there's a bunch of zeros coming, in front of it. This is just to make sure also that if we're dealing with, when we're playing around with digits, there aren't going to be any out of bounds issues. Okay? So 0, so let's see here. So what we're going to do here is use the tools that I alluded to last time. Specifically, we are going to make use of the same tool we did last time, which is to divide by 10 to remove a digit, and to modulo by 10, okay? In which case, that gets you the value of the very last digit, right? Remove the last digit, get the value of the last digit, okay? So what we could do here, okay, is say I've got a number. Say I've got a number like this, A, B, C, D, E, F, right? That's my number, where each of those is a specific digit, okay? All right, specifically this is, right? This is, oops. This is the ones place. Sorry, so this is the ones place, the tens place, the hundreds place, thousand. So 0, 1, 2, 3, 4, 5, right? So say I wanted to get I wanted to get 2, the hundreds place, right? I'm asking, so I'd be asking for n and a b c, sorry, not n, but 2 a b c d e f, where that's actually a real number with real numbers as opposed to a b c d e f, right? 2. That will give me 0. So what I'd want to do, I'd want to remove the last digit, then I'd want to remove the last digit again, which is doing it twice, and then I'd want to return the last value, which would be D. Okay? So I want to do that n times. Okay? So let's go ahead and get started. Public, static, int, we're going to be returning an integer again, and we're going to also do, this is called nth digit back, n, and then num, right? And those are both integers, int n, int num. Okay, return -1 again, so that we just simply get this quiet, so that again, we always want to have code that's going to run, or code that doesn't have an error, because we don't want any errors that we leave around. We don't want to leave any errors around on purpose, because that could make us miss other errors. Okay, so int n, int num. So we want to do this operation. We know we want to do this operation to remove the last digit, right? Num is equal to num divided by 10. That's what we did above. We want to do this operation, but specifically we need to do it a specific number of times. Specifically specific? I guess so. All right, we want to do this a certain number of times. A certain number of times. How many times? N times, right? So there's two types of loops, as we've learned. There are for loops, which are used for definite loops, and while loops, which are used for indefinite loops. Of course, you can mix and match. You can always arrange one in form of the other. But here we want to do this. We want to do it as a, we're going to stick with using essentially what comes most natural, which is the for loop. For loop, right, which looks like this, int I is equal to 0. If I put 4 here, this is going to run 4 times. If I put 5 here, then whatever inside the for loop is going to run 5 times. If I put a 10 in here, 10 times. And if I put an x in here, if x was a variable, it would run x times. We want to chop off the rightmost digit n times. So what should we put in here? N, and we want to do this operation multiple times. So that's what we put inside the for loop. So what do? We say int I is equal to 0, I is less than n, I plus plus, right? We want to do this loop. This is the format of the loop to say we want to do this exactly n times. What do we want to do? We want to remove the rightmost digit. Okay. Now we've gotten rid of those all those digits, all those rightmost digits, and now what's on? Now the current rightmost digit. The current rightmost digit is the one we want. So in this case, if we remove 2 of them, we'd have A, B, C, D, and we want to get D back. We want to get the last one. So this is where we use modulo. In this case, we would say we want to get the last digit of that, return num mod 10. So let's go ahead and say, instead of count digits, we are going to do nth digit back. I want to get 2, 1, 2, 3, 4, 5, 6. So in this case, we are looking to get 4 back. 0, 1, and this is at 10 to the second power, or 2, and there we go. There are a couple other ways we could do this, right? Since I mentioned that it was 10, we could try doing it with strings, although if we try doing it by converting it to a string, it gets as messy as the next one can be a bit, or it gets messier than the next one will be, because you have to do a lot of converting, okay? But also, since we know this is 10 to the, however many power, we could simply multiply 10 together that many times. We could also generate 10 to the nth power. That would be a fair move to do. And then simply divide that and then mod that. But yeah, that works. Let's go ahead and just test a few more things. What happens if I try to get the 40th, which is 10 to the 40th power, all the way out to the left? It's going to give me zeros, because every number, right, we understand that it's got a number of leading zeros. How do we get that? Well, we keep dividing by 10, and eventually we get to 1 divided by 10, which gives us 0, and then we keep dividing 0 by 10, right? We can always divide 0 by anything. It's dividing by 0, with 0 being the divisor that gives us issues. So we just it's just like multiplying by 1, right? In this case, we're dividing by 0. We keep getting the same thing over and over. Well, it's just by multiplying by 0. Here, dividing by 0, using 0 divided by something, that keeps getting us 0, right? And again, if I do the 0th place, which means none of this occurs 0 times, right? I is equal to 0. Is I less than 0? No. So it's not going to run even once. Run it. And that gets a 6. Excellent. Okay. Next problem.